And I have done church windows before with the drafting and design work that I do, and so I know the complexities that are involved in taking measurements from them and all that kind of stuff. And we went out and did this church just to have a little bit more of a recent video and something that everybody could understand. Like Ryan said, there were some parts that we sped up just for the sake of time, but all in all, this measurement that we did took about 30 minutes to do one window, and it came out pretty straightforward, and I'll show you the CAD files that we got from it and everything. So I'm going to get started. What we did was we went to the field, we recorded it. There's no audio that's going to be playing, so I'll kind of just walk you through what's going on as we're watching the video. And what happened was the 3D Disto itself has a viewfinder that you can kind of see what it's looking at and where it's taking the measurements. And then Ryan also set up a camera that he took some pictures, and he also, was taking some videos as well, and that'll be like a side-by-side thing, so we can see that as we go along. So I'm just going to kind of get going on this, and then after we're done with this presentation part, I have the 3D set up with this computer. I can show you guys anything else that you're interested in. So I'm just going to get going. This was a church, again, right around the corner from us, and these are just kind of the preliminary pictures that of the window that I was measuring. So the one straight in the middle is what we were measuring, and I just really wanted to get the perimeter, and it had a pretty decent edge that I could hit against to get the perimeter, and we'll see that in a little bit. So what you're seeing right now is the start of the software, and I'm using a mode called room scan. It's going fairly quicker. Basically with this we set a bench point, which I just picked as a point on the ground, and that's going to be every measurement above that is in the positive, and below that is in the negative. And right now I'm just moving the disto manually to get to a point that I would like to start from. This window was probably about 10 to 15 feet off the ground, so that sill was, I had to shoot from a bottom angle. Everything else kind of worked out well. And right now, the first couple of points I'm taking is really just at the top of the sill. And when we look at the AutoCAD file later, you'll be able to see what's going on. So I took the first couple of points manually, and then there's an automated scan that you can set up that I basically set it up so that it picked a couple of different points, and then it's going to scan a line between, which we'll see in a few minutes. So these first couple of points are just locating the top of the sill that's there, and a little later on I locate the bottom of the sill so we can get an offset to kind of work from. And now I'm picking the first point of my automated scan, and that'll be in a second. And you can see the video on the right is kind of what we're scanning. So basically in the automated scan, you pick the first point, and then right now it's asking if you want it to be perpendicular or at an angle, and I'm picking at an angle. I was using my fingers to touch the screen, so you can't see the mouse button, unfortunately, but right in the middle is the one that I picked. And then basically you pick another point on an opposite side of the vertical line that you want to scan, which I'm going to pick. I'm going to pick a point opposite, and then in just a second I'm going to pause the video and kind of tell you my reasoning. So I'm picking this point right kind of opposed to that. That's the farthest point that I can see with the disto setup. So what we ended up doing is if you were to take the disto and set it up straight forward, like straight on with the window, what would happen is there wouldn't be any contrasting vertical lines that you could really measure. You'd be measuring to the corner of the window. So what we needed to do is we needed to set it up so that we could actually see inside, see at an angle that planar surface that's vertical, so that I could have the disto hitting against it without any error. So I set it up on to the right of the window the first time around, and that's the scan that I just paused. And then what we do is we're going to relocate it to the other side to get the opposite side. So that's kind of why I'm doing it this way, so that we can. The disto is very visual, so really what you can see is what you can scan, and the most difficult part with these windows is basically getting a good vantage point, and that's what I was just explaining. So right now with the automated scan, we have the ability to set it up in distance increments. I went with 2 inches because it's pretty much going to give us something to work with. Now, granted, you have the brick there with like the mortar joints and stuff like that, but there's enough, it's not going to throw the measurements off that bad. So now I changed the distance increment to 4 inches, and we've sped this up. This is the part that we sped up because it takes just a little bit for the automated scan to go. So this is I wish the disto was this fast, but unfortunately not quite there yet. What happens too with this is the disto, I picked a point a certain distance away from the window, and then the second point I took was the same distance away from the window, or approximately the same. And what the disto is doing is, you can see it's kind of adjusting for that distance, and it gets a little close at the top, but it was really right in that crevice of the window, which is all I care about. And then as it's going around, it's going to back off just a little bit away from the window, and it really was pretty straightforward. Now, I was just sitting back waiting for this to get done. I wasn't picking these points manually. This is the machine, completely automated, doing it. So it's really just picking that start point and the end point. And you do have to keep an eye on it just to make sure that it's, picking the right spot. Because again, it's adjusting. You can see the cursor's kind of like moving in and out. It's adjusting itself to make sure that it's in the right spot. So once it got to that last point, it's done, and you can see the arc of the window is kind of right here. You can see that arc. Sorry, when I pause this video, it kind of fades. But and then it asks you if you're done with the scan, and I was. So I said yes, or I said no. I don't want to edit the scan. And now the next step that we had to do was we were going to relocate the unit. So basically, when you're relocating the disto, you have to pick 3 to 5 points that you can see from both points. So I just took a picture there just to take a mental note of where we were when we stopped. But basically, when you're relocating the device, you got the 3 to 5 points. So I picked the 3 to 5 points of reference, and I actually did 3 this time. And then I moved the disto over to the other side of the window. And that's what I'm doing right now. I'm just going to the part where we're going to secure the location. And then it's asking me to measure the 3 to 5 points. So this church was very nice. It had lots of little screws and nuts and bolts that I could pick. There's these metal decorative supports that they had. So I just picked the bottom corner of those, and those were on either side of the window. And this is, again, sped up for the sake of time, but you can get the concept. And then there was another point over here where there was a bolt. I like to pick points that are kind of stationary, something that's not going to move. The nice part about this feature is once, now this is me just saving the file, once you've located the device, I could basically pack this thing up, go home, and come back in 2 weeks, hit those 3 points of reference again, and I'm just going to pause it for a second so I can talk. Hit those 3 points of reference again, and it'll take up right where it left off. So it's really not like a you know, a temporary thing. It's something that's pretty permanent if you pick the right points. Basically, so when you relocate, what's kind of nice about the Disto is it automatically takes a picture at each point. So you can see here, there's a picture of the first support that I took, the second support that I took, and then the screw that I took on that ventilation unit. So when I relocated, so I moved it over about 10 feet to the left, and then I basically say, okay, I want to relocate the device back. You know, I want to secure the location using those points of reference, and it shows me the picture of what I need to, the points I need to take. So the first one is that first support. You can pick them in any order you want, and right now it's going through because when you move it, you gotta re-level it. So it does its thing. When you move it, it's got to be plus or minus, I think it's 4 degrees, and there's a little plumb or a little center line level in there. And once you got it set up so it's pretty close, it will go through and level itself. And let me sped this up just for time's sake. And now I'm locating that first point that I did before, that secure point that I did before. And the nice thing with the 3D is you can actually use it all completely automated, motor driven, or you can move it with your hands. So right now we're picking the those 3 points. And what I did too was just to verify that I was in the right spot. You can check the location of the points, and you basically just pick the point that you want to check and click it and hit OK, and the Disto will automatically move to that point. So you can really verify that you're in the correct spot, that the Disto is recognizing itself as the correct spot, and then continue taking measurements. So now I'm at a vantage point to the left of the window, looking at the right side of the window, so that I can see that inside corner very well. And I wanted to locate the base, the bottom of the sill, which is what I'm going to be doing next, just so that I had a kind of a reference of where that sill is. And I also have the height differentiation that I've taken as well, which we'll see in CAD in a little bit. So that's what we're doing right now. And I'm just doing an automated scan again, picking the first point. We're doing a horizontal one this time, and then picking the last point, and then it's scanning in between. So
Adam, is the Disto automatically leveling when you reposition it?
yeah, so again, I'll pause the video so I can answer that question. Basically, if the Disto moves at all, what you get is an error. It'll say, you know, Disto has moved, it's not level, and you'll be able to tell immediately if there's an issue. And when you're doing the moving from one point to the other, as long as you set it up and that center line level that's on the Disto is in a fairly center spot, so that the Disto can level itself. You know, it can't level itself if it's off more than like 4 degrees. But if it's in a good spot, what it'll do is it'll say that the Disto has moved and it wants to run a level check, and you just click OK, and it will automatically level. There's no manual leveling to the 3D Disto.
Blocking the windowsill, blocking the bottom with the bottom measurement. You're looking up at a church.
So you hear that, Adam?
Ooh, I'm sorry. What? I
what you're showing so far, the sill obstructs the bottom of the window. How do you handle that?
So what I did was that's what I'm doing now. I'm scanning the bottom of that sill, and I'll let it kind of do its thing because I'll show you what I did next. If you remember in the beginning of the video, I had picked a certain amount of points. So now it's going to basically run through this, and I'll show you. These points kind of, it got a little kooky because of that chip out there, but it gave me enough points to work from. Okay, so Once it's done with this, I'll show you the next points that I took are basically giving me the reference at the bottom of the sill. So now I'm going to move the disto up. And if you can see, this line right here is the top of the sill. It's chamfered for the water runoff, but that, if you follow that line around, is the top of the sill. So I took like 3 or 4 points of reference here, took 3 or 4 points of reference on the other side, and that's how I'm placing the bottom of the sill. And we'll see that in AutoCAD when we open up the DXF file. So I'm just zooming right in, making sure I'm getting a really decent point there. And then these are manual points I'm taking. And then I'm going to start the automated points right now. And again, I'm going to pick a vertical line. I'm going to pick a vertical line that's not perpendicular. And then I'm going to pick that start point, which is about an inch and a half from the actual window, but it's going to give me that opening very well. Then I'm going to pick an end point. Which is basically as far as I can see on this side, which is pretty much a mirror of what we did last time. I think I went to the top of this one just because we had scanned past it last time. And what's nice is, when you relocate it, you're still working in the same DXF file. It's not like I'm working with 2 files that I have to stitch together later. I mean, we're working in the same file, so if the points are overlapping, you can see it and kind of work from the CAD from there. So now, speeding this up a little bit so that you can see what's going on.
How long did you say it took to do this window?
It took a half an hour. So we sped this video up to about 15 minutes. So really the longest time was setting up and then doing the relocate thing. Everything else was pretty streamlined. Sometimes what's happening now is, like I was saying before, the disto will try and stay in a certain spot. And right now it's trying to, we pick that first point, we pick the last point, and it's trying to pick all the points in between in a straight line between those 2 points. If you were to do that theoretical line between those, that's what it's trying to be. Sometimes when you're scanning, the disto will kind of do some, it'll like almost lose its place, like where it is, and it tries to find it again. So right now you'll see the screen's kind of going all over the place, but it's just the disto taking measurements and trying to find its place, and it recovers in a little bit and then keeps going on the scan. And then I'm going to change, you can change the scan interval at any time, and that just gives you a little bit higher of a resolution between the 2 points. And it gives you a little bit smoother of a curve that you can work to. And then I ask if you want to edit it, which I don't. Got some. I'm just going to pause it for a second. Get some background noise here that I might get rid of. Root. Audio. Yeah. Perfect. Got it. All right. So now what we're doing is we're saving the file, and I've exported it. And now I'm going to open it. It was super cold that day, so I opened it really quick in AutoCAD and then shut it. I just wanted to make sure the laptop that I had it on does have AutoCAD on it. I wanted to make sure it looks fine and everything was good, and then I closed it really quick. And I'll open up the AutoCAD on my computer now so that you can see it a little bit better. But this was just me checking the file, which is, I suggest doing this, when you're in the field, you're right there. If you have an AutoCAD on your laptop or like AutoCAD viewer, it's pretty nice to be able to see it. So I was just zooming, and I'll show you in about, the video's almost done. Actually, I think I could probably just, I'm just going to pause it right there, and I'll show you the AutoCAD on my computer. So I took the files, and I basically just copied them, pasted them into here, and now I'm actually on my computer. What's kind of nice when it does an export, it saves 5 different files, and then any pictures that you took or secure points that you took, it'll save those as well. So if I come into this folder, these are pictures that it took when it was relocating. So these were the 3 points of reference that I used to relocate the device from one side of the window to the other side of the window, and it keeps those in its memory just so that you can go back and use those as a reference again. And then any pictures that I took while using it, it takes those as well and saves them. And I just took a picture at the point of when I was finished. And then these are the 5 files that it exports. The CSV file is really probably something that you're not going to use. What it's nice, it's opening up in my Excel on the other window here. So I got 4 screens here. So if you see something kind of go out for a little bit, that's why. What this is just kind of like XYZ coordinates. What's beneficial about this, or if you have any issues at all with your DXF files, and this TXT file is the same idea. If you have any issues at all, we've actually had a time when I went out, I did a scan, and I manipulated it a little bit in the field, and then when I came back and I tried to export the file, it was giving me an error, and we couldn't figure it out, and we ended up sending the CSV file and the TXT file, which were the only things that it was exporting, to Leica, and Leica was able to decipher the problem that was happening, the error that was happening, and they were able to export the DXF file. So I wouldn't ever get rid of these things. It's just a really good backup. And then it will give you 3 DXF files of the export. The first one is really, I honestly don't know why it gives you this one. It's really just like a visualization, like a fluffed out version. I never use it. And then there's 2 other versions. There's a 2-dimensional one, which if you're doing like templating in a horizontal plane, it's great for like countertops and stuff like that because it'll give you a flat shot of the plan view. But for the work that you're going to be doing, I'd say the 3-dimensional one is the one that you're going to be using. So when I open this up in CAD, this is right from our scan. What you're seeing right now is kind of from the plan view of the scan that we took. It looks a little crazy right now, but when I orbit this thing, it'll get a little bit better. So that's the window. And let's look at it from the front. The first thing that I do when I'm opening up a DXF file is I just change the point style. So this is the current point style. If I do DDP type, there's a shortcut to this too, but I'm just going to change it from an X to a point, and those will all disappear. And then if we, this basically sets up, there's like 4 or 5 layers that are default. And if we just turn off the Leica ID points, that will give us a more better view of the actual scan that we took. So you can see it kind of looks a little, it's a little bit messy, but that's the reality of the window that we scanned. So it's kind of the way it's supposed to be. Down here is the bottom of the sill. Right here and here is the top of the sill. So if we drew a line between these two, that would give us the location of that bottom sill. And then I would go through and, clean this up a bit. This is slightly intriguing why that kind of dies off like that, but I'm not too worried about it. And then what you could do is just from this scan, I would go through and work out a something that I could cut on a CNC machine and test it out. So I know when I was speaking to you guys before, you had said that what you do currently is you go to the site, you would either set up a scaffolding or a ladder and mount a piece of cardboard or something that's cuttable onto the window. You would trace that cardboard, you would cut that cardboard out so that it would be the same size of the window that you're templating, take it back to the office, scan that in or trace that cardboard into CAD, and then you would cut out a template and bring it back to the site to make sure that it fits. This would kind of eliminate all those first steps, and you would go to the site, you would scan it like we just saw, you would take this CAD model, clean it up a little bit, and then put it into a CNC program that you could cut out, quarter-inch Luan plywood or quarter-inch MDF or whatever you guys use to test it out, and then bring it back to the site to test to make sure that everything's right or do any tweaking there, and then you could have that as a template to work from after that. So kind of would eliminate quite a lot of steps between what you're doing now and what you could do with the 3D Disto. And I was there's a lot more things that I could have done to make this a little bit easier, I think. We just really wanted to get there and get the concept down, and but there's some things that you can use. Let me open up a picture just one second. I'm off on one of my other 4 screens, so that's why nothing's happening on the screen. I'm just going to open up products. Give me a second here, guys. 3D images. This is the delivery, this is what you get when you get the 3D Disto. And what I was going to show you is there's a offset, basically like a stick. So you put this point in something that you can't actually visualize with the 3D, and then you would target the first point and the second point, and the 3D automatically locates that point. The nice thing about this is you can actually custom make one so that it can be whatever length or size that you need, and there's some things that you could do with that. So kind of when I was having trouble locating that sill, 2 things were going through my head was I could just get it close, and then once the template is cut, with a CNC machine, I'll go back and just kind of like, that would be the only area of question that I'd have. I'd go back with that in mind and make any fine-tuning adjustments after, when we're bringing the template to the site. But the other option would be to come up with like an offset stick, because you could customize one that you could basically get into that corner and have the 3D take the points that are required so that you'll be a little bit better off in terms of the scan. But and then these are just basically a couple, these are the power cords, targets, remote control if you wanted to use it. You can use it with the tablet, you can control it all, or you can actually use the remote control to move the device around. And that's pretty much it. So one of the things that I'm trying to think here if I can show you anything else. One of the things that was kind of limiting for me when I was on the site, which really, I mean, the windows are 20 feet in the air. There's really not much I can do to get too much closer unless I was on a ladder. But what was limiting me is when I was recording the video for this, I had to be tethered to the 3D Disto via a USB cable, but that was only because of the logistics of creating the video. In actuality, if I was doing a site measurement and I didn't have to worry about recording, I could be wirelessly attached to the 3D, so you're not tethered with a cord. And I could be up on a ladder just making sure that my points are in the right spot, or doing that using that offset accessory to locate that sill as well. So there's a couple of things that I could do differently to make it go a little bit smoother. But all in all, I think you'd be able to walk away with this CAD model that you could then test out and make sure that the templates are going to work, and go from there with your windows. Another thing that I've noticed too, one more point, and then I'll let you guys have any questions. Another thing I've noticed with the 3D Disto is, yes, you can definitely do the templating, and I would do that the first couple of times around. But after you've gotten a pretty good technique around with this, you could probably forgo even testing it out to make sure, because I've done many countertop templating projects, and we're getting to the point where we scan it, it gets cut, it just drops into place, and you kind of move on to the next one. So I'm very trusting of these tools. They've never let me down. I've never had one let me down in all of the Leica models that I've used. But anyways, yeah, if you guys have any questions or comments or anything, let me know, and I'll see what I can do to answer them.